Hello children, welcome to the lesson. In this lesson, we are going to know about motion and its related terms in detail. Look here, motion in one dimension. What is rest and motion? Rest means a body is said to be at rest if its position does not change with respect to fixed points in its surroundings. Look here, a bench in a park is at rest. A book lying on the table is at rest. Cycles parked are also at rest. What is a motion? A body is said to be in motion if its position continuously changes with respect to its surroundings. Look here, a bird flying in the air, a boy playing with football, a rotating fan. These are all in motion. Observe carefully. Now, let us say scalar and vector quantities. Let us know about scalar and vector quantities. What is a scalar? The quantities which have only magnitude but doesn't have any direction associated with it are scalar quantities. Look here, time, mass, speed and distance, temperature, all are scalar quantities. That means there is no direction for these quantities. Observe these. Now, vector quantity. The quantities which have both magnitude and direction associated with it are vector quantities. Examples: magnetic field, gravitational force, displacement and velocity. All these quantities are called as vector quantities because they are having magnitude and direction. Now let us know about the terms related to motion. Distance, displacement, speed, uniform speed, variable speed, average speed, instantaneous speed, velocity, uniform velocity, variable velocity, average velocity, instantaneous velocity, acceleration, deceleration, all the terms are related to motion. These terms are related to motion. Look here, let us know about distance and displacement. Here, two houses are there. Let us observe. This is the path from this house to this second house. How can we know the distance between these two houses? Look here, a car is traveling through the path. The total distance covered by the car is called as the distance. Look here, look carefully. The car is moving from first house to second house. That is the distance travelled by the car. Distance means it is the length of the path taken by a body when moving from one point to another point. That means A to D. Here the displacement of that car is AD. That means the shortest distance between initial point and the final point. Displacement is the shortest distance between initial and final positions of the body. Now let us see the differences between distance and displacement. Do you know the differences? First one, distance is a scalar quantity. Displacement is a vector quantity because it is having direction. Distance travelled is always positive, but displacement may be positive, negative, or sometimes it may be 0. Distance travelled by a moving body is the actual length of the path. Displacement is the shortest distance between initial and final positions of the body. And distance is always greater than or equal to the displacement, but displacement is always less than or equal to the distance. Here let us see the example. Distance and displacement. A car is moved from A to B and B to C and C to D and again D to A. It came back to its initial point. From this figure, the distance travelled by that car is equal to sum of the distances along the path A, B, C, D and A. That is 5 plus 8 plus 5 plus 8. That equal to 26 kilometers. Now, what is the displacement? Displacement is the shortest path taken from A to A. That means it is in its initial position. So, displacement is 0. Now, let us see another example, distance and displacement. Here, a boy starts moving from A and reaches D as shown here. Now, what is the distance travelled by him? And after reaching position D, he turns back and moves to position C as shown in the picture. Then the distance travelled by him will be the distance travelled along the path A, B, C, D, C. Again, that is 4 plus 5 plus 3 plus 3 equal to 15 kilometers because he returned back to C. Now, what will be the displacement? Why the displacement is the shortest path between A and C, because the initial point is A and the final point is C. So, the displacement is 4 plus 5 equal to 9 kilometers. Now, let us see speed. Speed is defined as the distance travelled by the body in a given interval of time. It is a scalar quantity because there is no direction. Speed equal to distance travelled by time taken to cover the distance. Observe carefully. Total distance travelled by time taken to cover the distance. Units. SI unit is meter per second, and CGS system, in CGS system the units are centimeter per second. Let us see the example. A car starts from A and reached B in 4 seconds. A car is moving from A to B, covers a distance of 200 meters in 4 seconds. Then how can we calculate the speed? Speed of the car equal to distance travelled by time taken to cover the distance. That equal to 200 by 4. What is the distance travelled here? 200 meters. So time taken is 4. So it is equal to 200 by 4. Then that is the speed, 50 meters per second. Now let us see the types of speed. Could you tell the types of speeds? How many types are there? First one is uniform speed. If a body covers equal distances in equal intervals of time, then the body is said to be moving with uniform speed. Let us see the example. Here the motorbike is traveling with uniform speed because it covers equal distances in equal intervals of time. That means for each second it is traveling 5 meters. So it is in uniform speed. Next one, variable speed. If a body covers unequal distances in equal intervals of time, observe it, then the body is said to be moving with variable speed. Look here, this bike is moving with different speeds. That means in first second it travelled only 4 meters, and in second it travelled 5 meters, and third second it travelled 3 meters. So it is covering unequal distances in equal intervals of time. So it is variable speed. Now another one, average speed. How can we find the average speed? It is the ratio of total distance travelled by the body and the total time taken to cover the distance. Here the average speed of this bike, look here, total distance travelled 4 plus 3 plus 5, that is 12, by time taken 1 plus 1 plus 1, that is 3. 12 by 3 equal to 4 meter per second. How can we find the average speed? The total distance travelled by the total time taken to cover that distance. Next one, instantaneous speed. In daily life we are observing this on the motorbikes and also cars. It is the speed of the body at a certain instant of time when the body is moving with variable speed. Now let us know about velocity. It is defined as distance travelled by the body in a given interval of time in a specified direction. Here direction is there, so it is a vector quantity. It is having magnitude and direction, so it is a vector quantity. Now How can we find the velocity? Velocity is equal to displacement by time taken to cover it. Here we should use displacement, not the distance. SI units meter per second and in CGS system centimeter per second. These are the units of velocity. Now let us see the example. If a car is moving from A to B in the direction west to east, moving from A to B covers a distance of 200 meters in 4 seconds from west to east. The direction is given. So here velocity equal to displacement by time taken to cover it. Here what is the displacement? That is 200 meters. What is the time taken? 4 seconds. Here 200 by 4 equal to 50 meter per second. Towards east. We have to mention the direction. Compulsory. Now let us see the types of velocity. We have already known about the types of speed. Here, now we are going to know about the types of velocity. Now, uniform velocity. If a body covers equal distances in equal intervals of time in a specified direction, then the body is said to be moving with uniform velocity. Look here, this bike is moving from west to east and covering 5 meters per second. That means in each second it covers 5 meters. Here magnitude is there and direction is also there. This is called as uniform velocity. Do you understand? Observe carefully. It is having magnitude and direction. Now, variable velocity. If a body covers unequal distances in equal intervals of time in a specified direction, then the body is said to be moving with variable velocity. Look here, this bike is moving with 4 meters per second in first second, and it is travelled 5 meters in second, and it travelled 3 meters in third second. From west to east, direction is there. But it is covering unequal distances in equal intervals. So, the velocity of this bike is called as variable velocity. Observe carefully. The distances are different. Next, average velocity. It is the ratio of total distance travelled by the body in a specified direction and the total time taken to cover the distance. Once again, you see that it is the ratio. Look here. Observe this bike. Average velocity. Here, the displacement in first second is 4. Second is 5 meters, in third second 3 meters. The total is 12 by 3. Time taken is 3 seconds. So 12 by 3 equal to 4 meters per second towards east. We should mention the direction. Then only it is called as average velocity. Observe carefully. instantaneous velocity. Look here, it is the velocity of the body at a certain instant of time when the body is moving with variable velocity. Thank you for watching.